Starting with the ramp walker, we went to table tennis, now matchsticks. Let's do this one last time. I'm Pranav and this is the review of Gaurav's report opposing Adi Narayanan. Did I use Prezi? Of course. And to make things clear, the reporter is Adi and the opposer is Gaurav. There are a few mistakes in the methodology slide of the reporter's presentation. The slide states that the matchsticks have been glued together in hopes of reducing experimental error, but that actually increases the inaccuracy of the results, as there technically would be only one giant object in the box. This has been given as both a positive and a negative point by the opposer, Gaurav. But the sticking of the matchsticks will result in errors of predicting the number of matchsticks, which defeats the purpose of the problem. The opposer has missed that taking 44.1 kHz as a sampling rate of sound is generally used for professional music making, and it is definitely overkill for this purpose. 40 kHz is a better option, as the same results will be obtained. This is like trying to find the difference in quality between a 4K video and a 1080 pixel video playing on a 720 pixel screen. In the video of the reporter conducting the experiment, there is no measure taken for a standard force when pulling down the ruler, as it can be unknowingly altered due to the non-uniformity of the release mechanism being manual. This has been rightly pointed out by the opposer. The reporter's preliminary graph's y-axis, which is the decibel reading, contains negative values. If sound in decibels were to be negative, it wouldn't be heard at all. In the same graph, there are error bars which the graph is supposed to go through, but they seem to lay in random places and the graph barely goes through very few error bars. The graph also isn't exactly conclusive of the statement, although the theory may be right. These three issues, the negative decibel readings, the error bars, and the inconclusiveness of the graph, have not been pointed out by the opposer. Now talking about the derivation, whose purpose was to find the relation between the loudness of the sound and the percent of the empty space's volume. The reporter has taken the acceleration to be a simple harmonic motion, which means that the object's motion would be non-linear. However, the motion of the matchsticks inside the box is actually linear. This has been pointed out by the opposer and it is a very important point. This next mistake is a little difficult to find. 2 is in the subscript position of omega, and in the next step, 2 is in the superscript position of omega. This is a blunder which has not been pointed out by the opposer. While simplifying, C1 and C2 have not been specified as to what they equate to. The reporter has used V by V0 a significant number of times, so it's important to plot a curve and state that the value of it will always lie from 0 to 1. Both these points, C1 and C2 equal what, and a curve of V by V0 have been missed by the opposer. In the first raw data slide given by the reporter, the difference of the frequency is huge in the trials when there are 0 matchsticks in the box. This is while using the Apple matchbox. When using the home light matchbox, it is more stable. Again, the decibel readings should not be negative, otherwise they would not be heard. These are important points missed by the opposer. The opposer has pointed out the lack in clarity of the elimination of the XZ axis, but missed a checkmate. The graph of the XZ axis given contains 2 mistakes. 1. The sound produced in the initial phase when the number of matchsticks is just above 0 is lesser compared to the 0 matchstick case. That is not possible. The second mistake, the graph at around 5 matchsticks becomes flat. This means that the motion of the matchsticks inside the box during shaking is linear, but by assuming the acceleration to be a simple harmonic motion in the derivation, which is non-linear, it becomes a self-contradiction, making the derivation incorrect. The graphs of the Apple matchbox have 2 errors. The graph on the left and right indicate that the percentage of the empty space in the matchbox, which is the x-axis, can go beyond 100%, which is impossible. Another mistake is that both the graphs, when at 100% empty state, have a decibel reading above 0. When there are no matchsticks in the box, the decibel reading should not be more than 0. Once again, these have not been marked by the opposer. The opposer has also said that the graphs of the XY, YZ and XZ are similar, but the XZ graph is not at all similar to the other two. Coming to the chewing gum section, the reporter could have provided pictures to avoid confusion as to what shape of chewing gum he used, whether it was a stick type or a cuboidal type, and so on. There are no correct points made against the chewing gum slides by the opposer. The reporter also calls the curve as a Gaussian curve. All bell-shaped curves are not necessarily Gaussian. In the final slide of the reporter's presentation, it says that a sound spectrum is used. But the spectral representation of sound is not actually used, and it's only been done based on dimensions. To train a machine algorithm to identify a particular sound, 150 data samples are not enough. A number 10 times what was done by the reporter would be more practical. Finally, the discussion slide of the opposer could have been renamed to something else, in such a way that the intention of what the opposer expected from the reporter would have clarity. Overall, the reporter has done a detailed investigation, quite overkill however, and the opposer has pointed out some errors but did not elaborate much about the issues caused by those errors, and missed a lot of incorrect points in the reporter's presentation. So thank you. And as always, the end.